which can be both an empirical and molecular formula of a stable compound. So this question sounds a little bit complicated. I think the stable compound bit throws a lot of students off. Just have a look at which of these could be both an empirical and a molecular formula at the moment. So, CH2O. Well, that could definitely be an empirical formula. Could it be a molecular formula? So if the carbon had two H's and an oxygen, an oxygen, remember, has to have two bonds. Could that be a thing? Well, that can be a thing, and it is an empirical formula. So it could be that A is the right answer. We will come back and double check though. P4O10. Well, that's not an empirical formula because I can simplify that down. So that is definitely not correct. NH2. Now that could be an empirical formula if we were to scale it up. N2H4, that is something. That's called hydrazine. But NH2 on its own, that couldn't exist because nitrogen's in group 5. And so it'd have an unpaired electron here. There's an NH2 minus ion, that exists, but not NH2 itself because it just doesn't have the right number of our shell electrons. So this is not a stable compound. And CH3 we know is a methyl group. It in itself is not a thing. It needs something here. And so we know that that's also incorrect. So the answer is A.